All right, we're live. Cool. As Bo said, my name is my name is Chris Williamson. I am a network consulting engineer. I work for Cisco Systems. I've been here for the past 3 years. My background is in large U.S. wireless service providers, as you said. Before I came to Cisco to support a large U.S. wireless service provider, I worked at a large wireless U.S. service provider. And before that, I worked at another large U.S. wireless service provider. And before that, I was subcontracted 3 times to, yeah, you guessed it, a large U.S. wireless service provider. So I've worked at 4 of the 5 large U.S. wireless service providers, one of which doesn't exist anymore. It has rolled into another large U.S. wireless service provider. So I think I've got a theme going. So we're gonna pray this works. My clicker.
Do some fasting and praying.
Technical difficulties, please stand by. You need batteries? Oh, batteries good.
Do not attempt to adjust your set.
There we go. Just a few housekeeping items I'd like to take care of before we dive into the presentation. I know everybody in the room has one of these, maybe 2 of these, maybe more of these. I ask you go ahead and put them on stun. I realize some of you guys may be on call, so stun is fine. If it goes off, I will take it. So, is that you, Steve? I'm going to take your phone. I'm kidding. Just people, I realize, folks, you may need to take a call or do some talking during the meeting. If you have to, grab it, run out the hall. We appreciate that. As you will find out, for those of you who don't already know me, I'm a very interactive presenter. I might come up and start talking to you and having a conversation. So I like for you guys to interact. Raise your hand, shout things out. If you disagree with something I said, I'm going to encourage you to just tell me that you disagree with something I said. If you have a question about it, I want you to ask me. Don't wait till the end, don't hold me up, just raise your hand. Sometimes I may tell you, that's a great question, I'm going to come back to it in a second. If I don't come back to it, ask me again. All right, so just as a quick exercise, make sure we can do this. Can everybody do this for me? All right, now we know you can do it, so please go ahead and raise your hand at any time, ask me the question. All right, share your relevant experience. This is one of the great things I think about the user group. It's not me talking to you. I'm going to come up here and I've got some things that I want to talk about, but there are a lot of people in here who have far more gray hairs than I do. Okay? There are some people in here who have years of great experience. I see some of them in the room who I recognize. I'm going to encourage you guys to share that experience. If you feel it's relevant, please share with it. I have not done everything. This is a huge topic we're talking about tonight, QoS. There's a lot. So I may say, you know what, I have no idea what that means. If you know what that means, or you know an answer to somebody else's question, I'm going to encourage you to pipe up, share your experience. Okay? And last but not least, if you guys, everybody look above you right now, you'll see weird plastic things with a little black microphone sitting above them. All of them are live. So they hear you, everything you say. Every question that you ask will be recorded. Mostly that's for us to play back later and listen to so people understand what's going on. The downside is, if you decide to have a conversation on the side, we're going to record that too. So if you want to talk about something, have a side conversation, we encourage you to do that, but we ask, go ahead and just take a step out to the hall so it doesn't get recorded or it doesn't disturb the folks around you. Finally, as I said, this is an extensive topic. There's a lot to cover. I'm not going to cover all of it. I can already tell you that right now. I didn't put all of it in my slides. I didn't think we'd have time, and I wanted to make sure that we got through what I had put on the slate. We will talk about some things. I will mention some best practices. There are some situations in which the best practice is actually not a good idea. So please, before you go home and you pull everything out of your network and redesign it based on what you saw in the meeting tonight. Understand that your mileage may vary, and that the standard and the most used words at Cisco are, it depends. So please keep that in mind. All right, so our agenda for tonight. The first question that I get asked, and that I wanted to start with, is why does QoS matter? Has anybody ever wondered, you know, this QoS thing, we don't need it. It's crazy. Has anybody heard that? Has anybody ever had somebody tell them, QoS, it's not important, don't worry about it? Yes.
I had to beat him with a stick.
Yes. There are many people out there who will tell you, QoS doesn't matter. It's pointless. We run our pipes so big, it will never matter. Those are the people we beat with sticks. And after tonight, I will give you the stick to beat them with, right? That's our goal for the end of tonight.
And auto QoS people.
And auto QoS people. Well, so, but why is it difficult? Hardware matters. And one of the things that I kind of immediately scoped for tonight was we're not going to talk about hardware. If it's hardware specific, we're not going to talk about it because the brand and the exact switch that you buy, the model number matters. And that could be the difference between buying a 6509 Catalyst switch and a 6509E Catalyst switch. Their QoS may differ hardware-wise on those different platforms. So I don't really want to dive into it. So that, like I said, when I go and say it depends on what you should do, it depends, very much depends on what hardware you have in your network. And when you're looking at, I want to design and architect my QoS for my network and my company, it's going to start with what did I buy and what am I going to buy? And that's where it's got to start. Because if you don't have the hardware to do what you need to do or what you want to do, you can't do it. Every networking company is different. So as I mentioned, I've worked for 4 large U.S. wireless service providers. One second. At every single one of them, they've done QoS differently. Every single one of them. And it's not necessarily that it's entirely fundamentally different, but they make key differences business-wise between what's important to them. They make distinctions about what do they care about the most and what level of service are they going to decide is acceptable. So this is very important that you know not only your company, not only your network, but your applications as well. And what application you choose to implement for a specific vendor's application for a specific thing compared to another company who picked a different vendor to do the exact same thing will completely change what you need to do for QoS. This makes it really complex. The number of nerd knobs. How many of you guys have ever looked at a really complex QoS policy? Yeah, really complex. There's a lot of things. There is a vendor who I will not name. That is not Cisco. They have a product that competes with ours. One of the reasons that people like our product compared to theirs is we will build 12 lines of QoS. They will build 12,000 lines of QoS because there are that many knobs. And it's not that the Cisco one isn't doing all the same things. It's just maybe we've automated some of those a little bit better than they have. Maybe a little bit worse than they have. It depends. And the misinformation and myths. Now, you had a question.
Yeah, you say you work at 4 different companies.
Yes.
Well, you send packets to one of the providers, and you mark some like your voice calls high priority, and some like not so high. Do they care, or they just mark whatever they want? Will they pass it on their network and treat them better than others?
So you're asking from the telco side.
Yeah.
I'm on the telco side.
And you get packets. Some are high priority and some are not.
Good question. That's a good question. Hold on to it. I'll come back to it.
Okay.
I do actually want to make a distinction. So what the question he's asking actually has to do with wireline service providers. So you're looking at Ethernet service providers. I have actually, all of the customers and companies that I have worked with are consumers of that, not providers of that. However, that said, I do work for a company that also supports those. So I do have a little bit of insight into what's going on. But it's nowhere near as much as being on the consumer side. So just real quick, anybody here work for a telco, wireline telco? A couple folks. Excellent. Anyone in here work for another type of telco, not wireline? Okay, let's. And then everybody else, I'm going to assume everybody else in here, enterprise, some sort of production, consumer of circuits. Okay. So misinformation and myths. My network is dropping packets. This is the number. This is my myth number one. My network is dropping packets. Therefore, there is a problem with QoS. How many people have heard this one? How many people believe this one? Excellent. Okay, good. All right. So the goal for the end of tonight is for you guys to point out to me when we've dispelled these myths. And the idea is when you run into folks who are going to try to propagate these myths, that you'll be able to counter that with, no, that's incorrect, and here's why. That's what we want you to end tonight with. Myth number two. I've already mentioned this one. We don't need QoS. We purchase bandwidth in excess of what we consume, therefore QoS is not a problem. Myth number two. Myth number three. Setting the bandwidth or a shaper on the interface fundamentally changes the speed that the packets leave that interface. How many folks have heard this one? How many folks understand this one?
Yeah, understand.
A couple? Okay. Anybody scratching their head? It's totally okay. You're not alone, I promise. No one? Everybody's got it? Okay. I just want to make sure you're still awake. All right, so we'll talk about this one. This is a good one. This one will go in depth. I want you, when you figure out what this one is, I want you to raise your hand. Tell me. I figured out how to bust myth 3. Myth number 4. I will never understand QoS. So this is the ultimate myth that we want to dispel tonight. I will never understand QoS. So hopefully by the end of tonight, you at least, if you don't understand everything, you've got a stronger foothold. If you don't know what it is you need to do, what it is that you need for a specific thing, you know where to go. You know where to go to find the information. All right, so a quick overview of QoS. What is QoS? QoS defines the features that allow the transport of traffic and applications across our network with specific requirements. It's configured to allow to avoid or to provide special dispensation or configuration for packets that are sensitive to jitter, packets that are sensitive to delay. Voice, obviously, probably the best example of that. All right, our shaping, we'll talk about shaping and flexibility, shaping and policing, but MQC. MQC is what allows us to configure QoS across iOS. Did anybody, I'm curious because this actually doesn't apply to me, did anybody exist in the world and was a network engineer before MQC became a thing? We got a couple hands. Good. Now, the idea now is QoS is very straightforward. I can go from any box, any Cisco box, to any other Cisco box, and I can read the configuration because it's very standardized. It's very straightforward. Now remember, hardware matters, so it may be different, but for the most part, I can understand what's going on. All right, our QoS consists of 3 parts that we're going to talk about. First part is marking. What do? I mark packets. That's how I tell what the packets are. 2, my policies. What do I do with these marks now that I've taken out my red pen and made all these changes to the packets? What does that mean? What do I do now? And then finally, how do I turn it on or turn it off on a specific interface. My last bullet there. QoS does not occur until QoS does not kick in until network congestion occurs. I want you to keep this in mind. I think a lot of people think what this means is if I have a 1 gigabit interface and I'm only using 500 megs of traffic, QoS is not doing anything. True or false?
False.
False. It depends. That's a much better answer. That's the correct Cisco answer. It depends. QoS might not be doing anything. I might not have turned on QoS to do anything to that interface beyond what it's normally going to do. I might have. All right. So this is a slide I'll refer to a couple times tonight. This is a life of the packet. This is my life of the packet that comes into the router based on QoS. I don't obviously include routing lookups, all of that fun stuff. I just want to focus on QoS. So the first thing that happens when we enter, step 1, classify the packet. What is it? I need to know what it is. It's the first thing I got to know. Step 2, police it. Policing is typically done on ingress. The reason for that, we'll get to in a little bit. Step 3, I queue the packet. Now that I know what the packet is, and I made sure that I'm not getting too much traffic coming from whatever host, I put the packet in the appropriate queue. 4, I shape it. I need it to go out this interface. Okay? And I need it to go out this interface, and I may need it to meet a specific set of requirements, or I may need it to do a certain set of things when it goes out the interface with my shaper. And post-queuing. What happens in addition to my shaping policy? This is one of my favorite slides. I can't take credit for it. I really wish I could because it's a sweet animation. But this is what QoS does. And I think for most of us, we kind of understand this at a very basic level. We understand what it does. We have packets that come in, and they just come in. We don't know what they are or who they're from or what they're doing. They're coming in. We have to figure out, we have to sort them. We have to figure out what are they. Now we want to mark the packets. Now we want to organize the packets, right? Now that we've figured out what they are, we want to sort them and move them to where they need to go. And finally, we process them and send them. So this is a very basic level of what we just looked at, right? The process where we mark it, we police it, we mark it here, we queue it, we shape it, and then we do post-shaping things. So step 1, marking packets. Marking is the mechanism in QoS that we use to identify what the packets are. So if I have a packet, I need to have some way to tell this packet is voice packet, this packet is a web packet, this packet is part of my mission critical application that tells me what banking transactions that I need to process for that day. This is mission critical traffic versus this is Bob. Bob's trying to go look at Reddit, right? I need to know the difference between those two packets. Otherwise, I don't know what to do with them. Ideally, if you have a well-designed and well-architected network, you mark as far down towards the edge as you can. Marking, ideally, is done on the host device that generates the traffic. Okay? When you have a server that generates a packet, ideally, that server is also saying, I am this server and I'm going to mark that traffic. Yes?
We don't trust the server.
We don't trust the servers. That's a great point.
Yeah.
Anybody here a server admin and a network administrator? Okay, good. No one?
You can slide all the server admins.
Good. We don't trust server admins. They don't know what they're doing for the network. They sometimes, what is the server admin's job, right? To run their server and to get maximum performance out of their server. That might not go well with what gets maximum performance from my network. So I know that maybe I don't want to trust them. But maybe I have good server admins. and I've been in very many places where we have very good server admins, we trust them. We trust them, and we will accept what they send to us. We may mark it anyway. Yes.
You trust your Cisco phones.
Right. There are a lot of things that you do want to trust. Cisco phones are kind of the most commonly trusted device. There's many examples of that though, where you do have a good system. You either do have a good relationship with your server admins that you can say, we'll trust what you're sending me, or the device itself. You trust the device itself, so you don't have to worry about it. Your routers. This is a key point. Your routers, if you have a router, it will inherently trust that. If you do not want to take whatever it is they're giving you for that router, you must change or set what they're going to send you. Otherwise, you're taking, if they send you, hey, this is my web traffic coming in at EF. Congratulations, they just got EF markings on their web traffic unless you go in and overwrite it. For switches, it doesn't trust. Now this can be, most of the time that's a good thing. You don't inherently trust, you set it as it comes in on the switch. For those times where you need to transit traffic across a switch that's already come in and already been marked correctly, you don't want to reset the marking back to nothing. Or you don't want to have to run that algorithm of what is this packet after every time it crosses a switch. So you want to go in and maybe between two switches, you want to say, all right, these are my switches. I know that I built the policies right. Trust anything that comes from this switch to this switch, and vice versa. So we need to remember whenever we're transiting that switch, I need to trust my other switch. Because I trust what I did, right? We trust ourselves.
And when you trust it, it doesn't change the marking. So once it's marked, it's trusted through, it doesn't change the marking.
Exactly. Once we've trusted, we just say, leave whatever it is. Whatever it is, I will accept it.
We had a problem, a lot of problems, when we were running the lower end access switches because hardware matters. We'd run some 2950s, it didn't run the full QoS, or some of the Nexus didn't run the full QoS. We had to trust or mark at the distribution, and we've run into TCAM issues with that when we're trying to do other things at the distribution, the ACLs and everything like that. So it's very important to leave the marking down at the access layer.
Absolutely. So for those of you who are familiar with our enterprise model, we have access, distribution, core, and you may have some weird combination. Maybe you have a collapsed core, collapsed distribution, collapsed access, whatever. We always want to say down at the bottom, we're doing all the thinking. The end devices are going to do all the thinking. That includes, what is this traffic? What should I do with this traffic? In the middle, we don't want to do thinking. We don't want to think when we're crossing through our core. We want to switch those packets as fast as possible. So we want to try to offload all of our thinking processes, which include QoS, as far down in that access layer as we can get it. In the core, we just want to say as many packets as you can get through my network as fast as you can. So types of marking. Here's the different types of marking at each level. We'll talk about each one. Layer 2, we have QoS. Layer 3, we have DHCP. Layer 4, we have MPLS EXP. And layer 4, somebody argued MPLS is layer 2. It's MPLS, layer 2, layer 4, layer 3.5, whatever you want to call it. It's MPLS. You know what it is. All right, so our QoS header. So our CRS header lives inside our 802.1 whatever P header that you have. You can see it down here. Our user priority, 3 bits. 3 bits means we have how many values? 8 values. So we have 8 possible QoS values. Each of those QoS values can map up to DHCP. It can also map up to EXP. It also maps up to EXP. By default, it will map exactly. There's an algorithm, and you can go see what it'll map to exactly. If you want to overwrite that, you have to do that separately. Wow, that is hard to read. Okay, well, this is the DHCP or IP precedence header in your IP packet. I realize you guys can't read it. The first 3 bits here are IP precedence. Again, three bits gives us 8 values. Excellent. Then our DHCP is the next 6 bits, gives us a lot more. 64. There we go. 3264. Yeah. 64 different values that we can set for a DHCP. MPLS EXP. So those of you who are familiar with MPLS, we're going to put a tag on the packet, and it's 3 bytes, and that tag is going to be reserved for our EXP bit. One of those, actually, it's 4 bytes, or 4 bytes, 4 bits. The last one's reserved for some reason. We still haven't found a use for it. But the first 3 bits are EXP values. Again, that gives us 8. So you can go through, you can map QoS to IPP to MPLS EXP. As you change protocols, as you move layers, it's going to map exactly. So when you move from one layer to another, by default, the Cisco equipment's going to look at that and say it's a layer 2 packet, but now I'm using layer 3 to transit. I need to translate that EXP. Vice versa, I'm using MPLS. I need to slap an MPLS EXP on there. You can override that behavior. This is for your reference. This is a godsend. If you have not seen this before, go find this guy. I think it's like QoS values calculator version 2. I have this like pinned to everything everywhere I work. It's so handy. Whenever I need to know, it helps me when I'm looking at packet captures. It helps me when I'm trying to do conversions, all that fun stuff. This is your friend. All right. Marking. So, how many of you guys knew that there was an RFC that defined how you should mark packets? One person, maybe 2 people. There's actually it's an RFC. It's not telling you how you should. It's actually just a recommendation. It's guides. We think of them, what is the Pirates of the Caribbean? They're more like guidelines. Okay. This is our RFC 4594 guidelines for how you should mark packets in your network. And this is helpful if you have to pass packets from one network to another, or a merger, for different reasons. There may be, you need to exchange if you don't want to go through the process of remarking, which you probably will, there is a way you can standardize. There is a standard method that you can go to. And it splits them out into all of your traffic in order from most high priority to your best effort and scavenger. There are classes also associated with this, so there's actually 12 classes. If you go back to the last slide, you can see there's 12 classes there. This takes you back, because again, hardware matters. Sometimes you can't make 12 classes and put them on an interface. Sometimes you can only make 8, sometimes you can only make 4. This kind of walks you through how to lump those classes together into single classes to make sure that you're optimizing kind of your traffic for your network. So again, these are good reference slides for kind of going through and designing. Any questions about marking? Pretty straightforward stuff, right? All right, our queue types. Priority queues. All right, I want to show hands because this is where arguments break out between engineers. How many of you call it a priority queue? How many of you guys call it a low latency queue? Okay. Anybody do both?
They don't care.
True heathens. Any true heathens in here? Okay. So I am going to be referring to this tonight as a priority queue throughout the slide deck. If you refer to it as a low latency queue, please, whenever I say priority, just translate the word low latency. This type of queue receives preferential treatment. It goes in front of every other packet. As long as there is a packet in this queue, it is processed. I don't care how many other packets are waiting, I go first. He's got the VIP badge. He's walking to the front of the line. He's going out. This is where we really want to send jitter-sensitive traffic. Voice is going to live in this queue. Your video, for those of you who are doing real-time streaming video, your video is going to live in this queue. You allocate it, it is allocated. Now, because of the problem of you can have this guy always going first, right? He's got one packet in the priority queue and one packet in the non-priority queue. Priority packet goes. Now, a second goes by, I have another packet in the priority queue. Now I have two packets in the non-priority queue. The priority queue goes. I keep going like that, and I'm only sending the packet out of the priority queue. I never send the packet from the non-priority queue. What happens if I put something into the non-priority queue that's still kind of important? It just dies. It's dead. Shoot it. It might as well not exist. I start dropping it. So in order to prevent that, and we call that queue starvation. In order to prevent queue starvation, what we're going to do is we're going to police. We're going to say, priority queue, you get to go first. But once you and 8 of your buddies go, the next guy, he's out of here. We're going to throw him out. We're not even going to look at it. We're going to send some other folks. We're going to send some of the regular folks, right? Yes?
Does that cause any delay in your network? Because the packets that are in non-priority don't go before the priority.
It will cause delay for those packets that are in the non-priority queue, absolutely. It will increase, you will see your latency increase.
Yeah.
However, that's usually not a problem for the applications that are sitting in the non-priority. Those are usually in your non-priority, you have things that are not jitter or delay sensitive. So you'll have web traffic, right? What happens if my TCP packet gets stuck in my web queue, gets stuck in the queue, and my TCP session dies?
It'll just retransmit.
Retransmits, right? I have lots of mechanisms. I put packets in there that have other mechanisms of going about making sure that they get their data. What happens to a what happens to a voice packet that gets dropped?
Well, it depends if it's TCP or UDP.
Most of them are UDP,
Yeah.
but they're gone. That's it.
It depends on the codec.
Of course, the answer, it depends, but for the majority of voice traffic going UDP, majority of voice traffic is going to get dropped, and it's gone. You have no mechanism to recover that packet. If you're ever talking on a cell phone and all of a sudden you get that quiet period, or you kind of get that weird garble where it sounds like you got every other word, might have dropped some packets.
Is there any way to make it to where instead of doing like A's, because I know that's the standard, is there any way to change it to where you can like do alternating where it goes priority, non-priority, priority, non-priority, or is it only?
Yes, put everything in the non-priority queue.
But
Priority queue means I go in front. That's what priority means.
okay.
Yep. If you want something to alternate or share, they all have to be in the same. So priority queues will share space with other priority queued packets. So I can alternate between which types of traffic. So if I have video and voice, I can send a video packet and then a voice packet. But I can't send a video packet and a voice packet and then a web traffic.
Normally, you would rate limit to one queue
Yes.
so that it won't eat up all your bandwidth.
Absolutely. All of these, in order to put something in a priority, you must limit it. By default, you cannot put it into a priority queue and give it that VIP access without also saying, here's your cap. Here's where you start going away. So that's what we call, because we want to prevent that queue starvation.
I think in Cisco's literature, low latency queue has two components. Priority queue is one of the components. The other component is a class-based with-fit queue. That two combined.
Yeah, okay.
Read the comment.
So the comment was, priority queue or low latency queuing has two components, the priority queue part and class-based weighted fair queuing. I'm actually not going to go into all of the class-based weighted fair queuing and red and weighted red and stuff. That's a good point. There are other mechanisms to improve your low latency queue or.
Well, it's described in the Cisco literature.
Yeah. So our non-priority queues. So we kind of discussed this by discussing the other one. These are the secondary. These have secondary treatment. We are allocating these guys the rest of the bandwidth. Whatever the priority queues aren't getting, these guys get the rest of it. Usually they come with a lower precedence, right? When we're marking, we usually mark the priority traffic with a higher marking value, whether it's QoS, DHCP, DXP. They're usually getting higher values. Our lower priority traffic's lower on that list. The key word here, and the key difference, non-priority queues use any and all available bandwidth that is not in use. They use any and all available bandwidth. That means if your priority queue is not utilizing all of that link, but you've got a lot of non-priority packets that need to go, they will send, after the priority queues empty, they will send those non-priority queues. They will continue to send. They will not starve these queues like they will for the priority queues. Your bandwidth allocation, when you allocate a bandwidth value for a priority queue, you're allocating the maximum value. You're also allocating the minimum value. That value is right here, both maximum and minimum, same number. For your non-priority queues, you allocate a minimum value. There is no maximum value. If their minimum value is 1%, but nothing else is using that link, that class can use the whole thing, and it will. So don't think that you've limited your non-priority queue traffic to a certain amount. It'll use the whole link. So a quick summary of what we just talked about. Our bandwidth command, which is our non-priority command, has a minimum bandwidth guarantee. It does not have a maximum bandwidth guarantee, and thus no built-in policer. It does not provide low latency. Our priority command provides all of those things. So why do the queue types matter? We've kind of talked about this a little bit. I put here two examples that you'll run into. I'm sure, does anybody not have voice or video on their network? Really? Okay.
Voice is coming in January.
Okay, yeah. Voice and video are your two examples of usually what you put in priority. And video, maybe, depending on what type of video, it may not go into that priority queue. Usually when we're talking about video, we're talking about live streaming video. So fireside chats, multicast.
Home alarm systems.
So why do these matter? We really start to notice human beings actually are able to detect jitter and delay within audio and visual cues at a much higher rate than they're able to tell what the latency is for something like an application. And the reason is, obviously, we have the stimulus. We have evolved through history to give priority to audio and visual cues, and especially ones that are lined up. So if you listen to something, you actually notice, I believe it's 180 milliseconds, where you start to notice that voice sounds real weird. It starts to sound real choppy. 180 milliseconds. 180, now, can anybody here tell me the difference if you saw your web page load in 4 seconds, or if you saw your web page load in 4 seconds plus 180 milliseconds?
Depends on if you're using IE or not.
If you actually go and look at the timer, you can tell. Maybe.
Or if you're listening to a modem style.
Just use.
Not really, and even video less so. Our auditory systems are actually more acute, so video, we can actually go a little bit further. We can go up to almost 300 milliseconds before we start to notice that weird video chop.
That's why we could create movies.
Yes, exactly. Our brain can kind of fill that in. But we notice audio, we notice video, we notice those long before we'll notice anything that has to do with other usable functions. Our brain just doesn't process anything except sight and vision as quickly as it does for these two guys. All right, so shaping and policing. How am I doing on time? I'm behind. All right, shaping. Shaping is what we use to set our outgoing rate from exceeding a configured rate. We accomplish this by creating queues and putting packets in the queues until a certain configured time, which we'll talk about how we configure time, and then we send a certain number of packets. So our shape is how much and how long. How long do we wait, and how much do we send after we've waited that long? Over time, our bit rate will not exceed the shaping rate. I'm going to actually make an exception to that rule here in a second, but over time, we're going to hit that rate that we shape to. If you're sending maximum amount of traffic, you will shape and you will watch it, hit that curve and ride exactly at the rate that you're sending it. Now, if you look at it within microseconds or milliseconds, you may see variations, but over large periods of time, it's going to match, it's going to be an asymptote right at that line that you set. It's based on the committed burst or the peak burst, which is our exception. This is our proactive solution. This is what we do before it's a problem. This is what we want to do on every interface that is going to something that we don't know what's going on the other side, because we don't want them to be the problem. We want to solve the problem before we give it to them. Policing. This is monitoring the incoming. Okay? So why don't we shape on incoming? Anybody have an idea of why we don't shape on ingress? Can't control it. I have no idea what's going to come next. Do I queue this packet or do I process it? I don't know. What packet's coming behind it? That's what we do with shaping. With shaping, we're looking at packets and we're saying this one goes first, this one goes next. We're putting things into queues and saying this queue gets processed and this queue gets processed. With policing, we're not doing that. With policing, we are taking and we're saying, as you are coming to me and as I get you, I am going to process you right then and decide, do you go? Do I downgrade you? Or do I drop you? That's why we do this on ingress, because I can't predict what the next packet is. Can't predict, is the next packet going to be a web packet or an OSPF packet? Because if I only have cycles to process one, I need to make sure I process that OSPF packet, probably. So if our monitored rate exceeds, we have two options. We discard it, or we can process it and remark it. We'll talk about remarking it a little bit. This is our reactive solution. This is somebody else is having a problem and we're trying to fix it. So what does this look like? This is my favorite slide. Traffic. I'm sending traffic. It's spiky. It's bursty. What happens when it gets to me and I'm policing it?
Chop it.
Chop it. I just start dropping packets. As soon as I'm out of bandwidth, no, too bad. Throw them on the floor. They're done. Shaping. Okay. Shaping, I say, well, oops, I have too many packets. What do I do with these packets?
Put it in queue.
I queue them. I say, okay, I'm going to hold on to these packets for a little bit. And then I don't have enough packets. Oh, cool. We'll go ahead and send these packets. Over time, we get a nice traffic rate that meets exactly what our shape rate is going to be. So you remember this guy?
Comment on the shaper real quick. On our MPLS, a lot of the times we'll shape the 90% or 95% of the total because it's some overhead. You don't want to exceed, so you want to kind of go a little bit under. And a lot of the vendors won't, per SLA, won't allow you to exceed it. And by putting it 95, usually you're safe that way. And you can actually get better throughput that way than to try to let it peak to the max.
Yeah. That is a great point. It was like 20 slides later in my presentation, but it's perfectly fine. No, it's a good point. And you have to, one of the things, right, is we're trying to proactively prevent, and usually when we're trying to proactively prevent problems, we're trying to proactively prevent somebody else from having a problem with our traffic. think I'm handing my traffic to the telco, right? I don't want the telco to drop my packets because I accidentally sent them too many. I'll hold on to my packets for a little bit and then send them to the telco to make sure they don't get dropped. As part of that, one of the good kind of best practices is to account. Remember, your telco's got to figure out and organize your packets in some way. So they're encapsulating them, more than likely, in some fashion. Whether that be .1Q, whether that be an MPLS header, they're encapsulating it. So you need to account for, well, I might have some overhead that they are going to have, but they don't give you that. They're not nice guys. They don't account for that overhead and take that into themselves and just say, oh, this is just the cost of doing business. No, they say, no, we gave you a 100 meg circuit or a 1 gig circuit or whatever it is. You eat that, our 4 meg cost in it, usually provides you performance benefits, as you said. Yes?
The policing, there's a little forgiveness in it. There's usually a max burst size, so you can burst a little bit and it won't get dropped.
It depends on the policer, but
Service curbs are common on like home internet connections more than.
some, yes. There are policers that will not, there are no tolerance, zero tolerance. And I can tell you for a fact, I've watched many folks have their traffic dropped. The bit that they went over, that whole packet got dropped because they were 1 bit over, right? That's terrible. You're like, come on, it's a bit, it's a byte, it's whatever, just take it. No, they won't. So some of them will have some sort of mechanism, and we'll talk about that here. But there are many that won't. And we mentioned this here, right? And we talked about this is where I want to do my policing. This is where I want to do my shaping. This is where I want to react to what people send me. This is where I want to proactively change how I'm sending the traffic to the next guy. All right, so this is our deep dive. All right. So there's different types of shapers. You have a shape average and a shape peak. Shape average is I want to hit a CIR, right? Everybody familiar with the term CIR? Anybody not? Okay. I have my CIR. I want to hit this number. And I want to hit this number on the dot. I want to shape average. That means that no matter what, my traffic will go to this value, will never exceed it. I may go under it. I will not go over, because I am going to go average to that number. The formula that we calculate for our committed information rate when we do our shape average is our committed information rate is equal to our committed burst divided by our interval. Do you guys remember when I said earlier, what is shaping? Shaping is how long do we wait, how much do we send? Okay, so I get to pick 2 of those 3 values to set. I can either choose how much I'm going to send and how long I'm going to wait. That's going to tell me automatically whatever my committed information rate is. Or, more than likely, in a real-world scenario, you know what your committed information rate is. The provider said, here is your committed information rate. This is what you purchase. When I go to set it on the router, I can choose to set how often I send packets to the provider or how large of a how large of a burst I'm going to send. We'll talk about the trade-offs between which one you're going to want to choose a little bit later. Peak information, shape peak. Shape peak is we're now going to use a peak information rate. That means every once in a while we may go above what they've given us. Peak information shaper is very uncommon in these days. Most providers don't sell it. Most people don't want it because it's inconsistent. It's much easier just to do the shape average. Anybody using peak information? No? Excellent. I won't mention it again because, all right, policers. All right, so how many folks, this is where you start to lose QoS. Dual rate, tricolor, single rate, two color. All right, so I've tried to boil it down a little bit. All right, so I'm going to talk about a single rate two color. So I have a committed burst value. Okay, this is the value that I am going to accept from the other side. And I like to think of the single rate two color as that old game, red light, green light. You guys remember that game? One person stands up at the front, and everybody stands on the other side of the room, and they turn around and they yell green light, and everybody starts running. And then they turn around and they yell red light, and anybody who moves after that is out. That's what this is like. They yell green light, and when they're out of bandwidth, they turn around and yell red light. Any packets that keep coming at them, they drop them. They're gone. Okay? Red light, green light. Single rate, two color. This is the thing that you're going to run into the most often. And this is where there's no forgiveness. If you exceed this, if you move, you flinch, they see you, you're done. The packet's dropped. All right, our single rate three color. All right, so this is where it gets a little more complex. So we're gonna toss the red light, green light game. So we're gonna police at whatever the rate is. Okay. So if I have, we'll make it easy. I have 100 meg. So I'm gonna police you at 100 meg. And if you send me exactly 100 meg, I will allow you to continue sending me exactly 100 meg. If at any point you send me less than 100 meg, you send me 96 meg, I'm going to say, that's cool. You send me 96 meg. I'm going to take it and I'm going to put it in a bank account for you. It's going to sit over here. Okay? You got 4 meg. You keep sending, now you go back to sending me 100 meg. Later you only send me 50 meg. That's cool. Put it in the bank account. You have 54 meg. You can burst, you can use, at some point you say, oh, I need to send some more traffic. We just had a spike. You can use what's in your bank account. That's like a debit card. You can't go below 0. Okay? You spend that, as soon as you say, well, I want to send this much traffic, it's 55 meg. I got 54 in the bank account, buddy, dropped. I want to send this much, it's 53 meg. Ah, okay. You have 54 meg in the bank account. That packet goes through. I'm going to withdraw 53 meg from your bank account. You're down to 1 meg again. There's a little bit more complexity involved in terms of the timing. That's the fundamental, how is this going to work? Okay? Single rate, 3 color means I'm going to give you kind of forgiveness. I'm going to have like a bank account for you that you can pull from. I may change your marking on the packet. Now, most providers won't do this. I haven't actually seen anybody do change of markings based on this, but it is possible that when they say you've exceeded your committed rate, this is a special packet we're allowing this one time, they could remark that packet. Most of them will not, and you will not see the end result of that usually. 2 rate, 3 color. Yes.
So where do you see those policers, the packets like Spring Relay, ATM, Metro E, what type of service?
All of the above.
Repeat the question.
The question was, where do you see these policers applied kind of in real life? The answer is, you see them in a lot of different places. Single rate, 2 color, Ethernet circuit. A lot of Ethernet circuits will use single rate, 2 color. If you have ATM circuits, you'll see one of these. Pretty much every provider of some sort is going to use one of these on the other end. Very rarely do you see this within your own network, unless, like I said, you don't trust that server admin to do what he's supposed to be doing, then you might police his traffic. But for the most part, it's usually not deployed within let's say, a data center between 2 nexus. You wouldn't have it shapered on one side and a policer on the other. Usually you're running those wide open to try to get the maximum amount of bandwidth throughput. 2 rate, 3 color. This one's always trippy for me, and I always have to think about it because you have 2 buckets now. You have your committed burst, and you have your exceeded burst. And we're filling up. We're allowing you to fill up both simultaneously. We're filling up the committed burst at 1 rate. We're filling up the exceeded burst at an entirely different rate that's just as fast, if not faster than your committed rate, or it is faster than your committed rate. Whenever you send a packet, that packet counts against both buckets. So you have to subtract it from both sides. So your committed information rate, you say, I sent a packet, counts against my committed information rate, pull that number of bits out. Also, counts against my peak information rate, pull those numbers of bits out. So once I get to a point where I go to send a packet and I look in my committed information rate and I say, there's nothing here, I can't send packets against my committed information rate, I may be able to look at my peak information rate and say, aha, I do have some burst here, let me go ahead and send some using my peak information rate, and then it's considered exceeded. This allows a little bit more consistent burst. So for folks who are saying, we burst a little bit all the time, and we don't want to have that stored credit already before we start using it, this allows you a little bit more consistent burst, as opposed to a bursty burst. So for those who didn't, neither of those made any sense. I stole these from INE. I thought they had the best explanation for what these look like. For your single rate 3-color, right? Our single rate 2-color, red light, green light, we don't need to see the buckets for that. Single rate 3-color, I'm filling up this bucket. Anytime I have extra in this bucket that I don't get to use, throw it over here. But I only fill this bucket. Okay? My extra goes into the other bucket. For my 2-rate 3-color, fill both buckets simultaneously, and I'm filling this one equal to my committed information rate, so I'm filling it at, we'll say 500 meg, while this one is getting filled equal to my peak information rate. My peak information rate may be 600 meg. Yes, question back.
You might point out that what you're putting in the buckets here are tokens that can be spent towards sending packets. These are not packets going into a queue bucket. These are
yes, thank you.
Tokens that say, all right, you're filling up your bank account. This is income into your bank account that can be spent to send packets.
So the comment was, these are not queues, but these are banks of essentially bandwidth that you are able to spend at any one particular time. So don't think of these as you are queuing packets in any sort of way. These packets are going as soon as you have the availability. They're getting spent immediately. There is no queue mechanism. Remember, this is coming in. We don't really have a way to queue things coming in to wait for them for us to figure out which ones we want to process. We have to process them on the fly. Therefore, we spend this on the fly. There's no.
And the other thing is that top line there, that BC, it's like your bank account has a maximum value. So you can make all the money in the world, but if you filled your bank account to its maximum value, you can't put any more money into the bank account. That's your committed burst rate there, or the BC. And the same thing for the BE. It's like this is a separate account, and you can only put so much in it before it won't accept any more.
That, again, an excellent comment. The BC values and the BE values are capped. There is a maximum value that they can reach, and you cannot put anything more into it. So, for example, you can't say, you know, Mr. AT&T, I'd like to buy a circuit from you, and not use that circuit for an entire year, attempting to bank packets, and then try to burst, you know, a ton all of a sudden out that one interface. It's not. They're gonna call you and say, what are you trying to pull on us? It doesn't work that way. There is a maximum value.
Does it have rollover? Oh, that was Stan.
Yeah. Yeah. We're working on the rollover feature, but all right. Questions there? Yes.
What if you have extra tokens in this scenario? If you're filling both buckets simultaneously?
I'm sorry. Wait.
Yeah, this one.
Okay.
If you have extra tokens, where do they go? Do you have a secondary bucket for that?
If you have, I'm sorry. So if you have extra tokens.
Where do they go? Because you said they fill up simultaneously, right?
Correct. Okay. So the question was, where do the extra tokens go in this situation? The answer is, there are no such thing as extra tokens in this situation. You're spending them simultaneously. All the ones, if I have a 100 meg packet here, I have a 100 meg packet that I need to send, I have to spend 100 meg of tokens from this bucket and 100 meg of tokens from this bucket in order to send that packet.
Yeah, the other bucket is called the bit bucket.
Yes. The extra bucket is the bit bucket.
I would say it's equivalent to, you go into slower speeds after you reached a certain, limit, kind of like the other options rollover, except not in just memory.
Are you referring to the
Yeah.
three color?
Yeah, this one, and the opposite way of, forgot what I was saying, really back, but rollover when a lot of companies, you get to, 10 gigs, or so you go to 11, right, but it gets slower after 10. And we kind of convert it in this way, just in an opposite manner.
Well, yeah, so the comment was, in rollover, they slow you down.
No, it's not rollover, it's the other option. Like if you have 10 gigs, it's unlimited data, but you have 10 gigs that are high speed.
Mm-hmm.
After 10 gigs, it slows down, but you can relate it to that, but with speed up, what we're talking about.
Okay, I think I understand what you're saying, but yeah, so at no point, during this, will it slow down though? Yeah.
Well, no, well,
Yeah,
not,
but I get what you're saying.
just, it would
Right.
just go faster,
Right.
kind of.
It allows you to use a little bit extra.
Yeah.
Yeah.
And instead of
Rather than slowing
slowing down,
down.
give you the other.
Right, rather than slowing down, it lets you use a little bit extra. All right, so how do shaping and policing interact? This is always a fun topic. So most people's questions when it comes to QoS is when they get real complex and they see like real world scenarios where we've built something that is 2 and 3 and 4 and 6 lines deep, and you have to recurse all over the place trying to figure out, well, this calls this and it goes here and it does this and then this. Oh my goodness, what am I doing? So real quick here, shaping and policing interaction. I wanted to give you kind of a, what can you do? You can police as part of a shaper. If you have a certain amount of traffic and you're saying, I want to shape this 100 meg, I want to shape this 100 meg out to you, but I'm going to police and I'm only going to send you a certain amount of web traffic. I can do that. I can police my web traffic to you while still shaping the total traffic that I'm sending to you. Remember, this is exactly what the priority command does. The priority command says, I will not send more than whatever that number is to the person next to me. I can put that as part of my shaping. I can have a priority command go to my shaper. You can shape as part of a shaper. All right, now we're getting into inception, right? I can shape my shaper. This is where I can say I want a very specific class and I want it to achieve approximately this rate. And then I want it to go into a bigger class where it has more things that it has to compete with, and then I want it to give approximately this rate out of that group of classes. So I can have web traffic, and I can shape the kind of web traffic that I want to send, and then I can send that in, and I can say, okay, now that I've shaped and I've got a good organization of what type of web traffic I want to be sending, go into my master policy, and now you've got to compete with your voice, your video, your height, your network protocols, all of the really important things. So now I can shape down to my shaper. This is called, typically it's called parent and child. We'll look at it in a second. Finally, you can police as part of a policer. So if I really want to, I can say you're only going to get, if I wanted to build a policy, the most complex policy policer I could build. You say I want to police my traffic to 500 meg, but I then want to police the voice traffic to 400 meg, and then I want to police the voice traffic that is going to George's phone down to 200 meg because I don't like George. I want him to get bad quality.
That's nice.
So you can police inside of policers. No, we're not shaping inside of a policer. Once we've policed something, we're not going a level down and shaping.
And you would police the policing policer if you know you have a noisy neighbor or a noisy application that is problematic, and when it ramps up and kills everything else, you've been known to chop it off and tell them to throttle it back.
That's when you sit there and you
Like somebody
call it system, server guy.
The server
Yeah.
admins again.
Yeah, well, a classic example is when they'll turn on like SnapMirror or something like that, type of replication.
Okay.
And you tell them you're trusting the NAS folks to throttle it back, and then they change something, they upgrade something, all of a sudden the throttle goes away, and then it kills your circuit. After a couple times of that, you police that and say, that traffic, that SnapMirror traffic, I'm gonna limit it to this. If it goes over that, it's dead.
And it's within another kind of global type of traffic that you have. Yeah, exactly. So the comment was that maybe within a specific type of traffic, you have one troublesome application, or maybe not even one application, but one server within the application that, I don't know, it's got a faulty NIC card in it that all of a sudden just decides to send wide open every once in a while, and you just want to say, yeah, no, you're not going to get to do that. So parent and child policies, so I just mentioned that. So real configuration, we're talking theory, right? We want to look at router configuration. So what is a parent-child policy? So the parent, I've got a policy map, and I'm going to call it my shaper, because this is my shaper, not your shaper. And inside of that, I have class default. Now, have I built class default?
Nope.
Do I have to build class default? Nope. Does it exist on the router despite any efforts that I do? Yes. Class default always exists. If I don't define class default within my shaper, will the class default exist? Yes. It auto-populates, whether it's explicit or implicit. It shoves it in there for me because it's like, you forgot the default class. And it wants to get the catch-all. So within this, I have a class default, and I have no other classes defined. But I've said my class default is going to shape to whatever value I set here. Looks like 100 meg. I might be off by 0. So I want to shape it, 100 meg. Cool, here we go. But before you shape that, go look at my child shaper. Before you decide whether you can send a packet, I need you to go look at this other shaper. So odds are, hopefully, some of you guys have seen something kind of similar to this. Yeah. This is not a very complex version of it. You may have a more complex version of it. But now I'm going to call the policy map my child shaper, and I would say, hey, web traffic, class web, you're going to get the remaining bandwidth at 40%. My video traffic is going to get the priority percent. My voice traffic is going to get priority 40%. Wait a minute. Did I make a mistake?
No. Remaining.
Bandwidth remaining. Right. I have 40% and 40% plus 40%, which equals not 100%. I can do that as long as I put the bandwidth remaining. If I left the bandwidth remaining off and just said bandwidth percent 40, this thing would freak out on me and it would be like, you can't add, dude. You need to go back to math. All right? And so I can do some fun stuff, right? I match my web traffic. I've got an access group that matches web traffic. I've got a class map, right? I've created a class map that matches my video. For some reason, I have SIP in there. Whatever, right? Because I clearly have the voice traffic that matches DHCPEF. That'll catch my voice traffic, right? My order matters. And why did I just tell you that order matters after we looked at that policy?
You didn't do it right.
Didn't do it right? What do you mean it didn't do it right? I had voice. Voice is going to look at EF, right? Voice, according to my RFC 49, whatever it is, that's EF traffic.
But you've already classified it as web traffic.
I've already classified as web traffic. Are you sure?
Classified it as
So order matters. So I want you to keep this in mind. When we build the policy, it reads it in order. So access list. Permit, I have an IP, deny, any. What does the rest of my access list matter? None. End of line. I have 130 lines. It doesn't matter what they are, because I already denied all my IP traffic. This is going to be the same thing. Once I've matched, I don't match anymore. I take the policy, I inherit whatever that class is, and I use that policy. So for best practice, we build our policies. We want to build the things that are priority first, because we matter. Those matter. We've already decided. These are the things that are important to us. We want to build those first. The second thing, we want to build narrowly defined classes first. Okay? So after we have priority, now we need to put non-priority, or we may need to decide between two priority classes. Narrowly defined, we want to put it at the top. Broadly defined, we want to put that down, because we don't want to catch that. We don't want to catch our deny IP any first. We want to put that as far down as we can. Finally, last but not least, our best effort. Yes, you can put class default at the top. It's weird. So let's look at our previous example. Oops. I have web traffic. This is the first traffic I look at, so what is my web traffic doing? It's matching my access group, and I now have an access group. Access group actually changed from 100 to 101. But my access list is matching anything that is coming from my 10 network. What if my network is the 10 network?
Just put it back right onto your own network.
Match IP, any, done. All my packets coming from the 10 network are web traffic. Well, what does that mean? That means that they're going to get bandwidth remaining 40%. Okay, well, let's keep that in mind. Video traffic. Okay, well, I've matched my DHCP values, video values, AF 41, 42, 43. I have that zip thing in there. That was probably not the smartest thing, because what am I catching with protocol SIP? I'm catching some voice traffic in there, aren't I? Uh-oh. So all packets that aren't from the 10 network, which we have established may not be anything, are now getting shoved into video if they are AF 41, 42, 43, or, because of my match inning, or their SIP. Oh, shoot. I'm trying not to get fired here. I'm not doing a very good job. Finally, I got my class voice. My voice is exactly what I want it to be. I want it to be class match any voice, my DHCP value of EF, which is standard. Typically, you will see that across all networks. That makes sense, except it's anything that's left after I've already matched the other two. So not a lot left, plus it's only matching EF. Everything else getting shoved into the default. So I'm now matching. So what am I doing? What might I be seeing in my network now? I'm seeing voice and video traffic both go into the non-priority queue. I'm seeing them both take delay for the few packets that I do get into the voice packet that have somehow managed to get into my network. The one guy who's got the 192.168 phone. Yes?
Yeah, that's why we always put our phones, or most of our phone stuff on its own Class B, or multiple Class Bs in our size of the network, and we keep it entirely separate from the data network. That way, if you do have web traffic and you decide to do something silly like that, usually you do it by protocol or whatever. Absolutely. But if you do something like that, you wouldn't lock out your voice stuff, because your voice stuff's already on its own dedicated set of /16. You use 10 space for it, though, as most folks do.
Yep. So the comment was keeping your voice network and your data network can help to mitigate that. How many folks actually have that implemented, whereas how many folks have it, they're running on the same network? Really, everybody's got them separated.
Yeah, I keep them too.
Okay. That's not always the case. VLAN. I'm sorry? VLAN. VLAN.
Put them on separate VLANs and subnets.
VLAN.
Yeah, it's on a different VLAN, and it's on an entirely different namespace.
Which is good until it goes through my core, where my core is MPLS. My core didn't care.
That's when it all comes together, so if you're only keeping it separate there on the local, maybe,
Remember,
core or building basis, and then it hits the core and it's put together with everything else.
remember, unless, if I have an entirely physical different network for video and data, or for voice and data, I've solved this problem, but that requires me to build an entirely separate infrastructure, which some folks do, it's just a little bit expensive, but some folks, I will say, some folks will do it. You have a question?
I could be entirely wrong about this, but wireless phone companies probably learned something from this. Although I might be interpreting this wrong, because I don't know what they do.
You're not interpreting it incorrectly. So you pointed out that wireless phone companies have this problem, right?
Voice and data.
What does this do? Does this do voice? Does this do data?
Yes.
They connect to a different network to do both of them?
No.
No. They're running across the same network. Yes, this is huge for wireless, and I can tell you from experience, this is a huge deal for wireless companies.
Yeah, well, I have Sprint right now, I just switched.
So one I haven't worked for, so.
If I remember correctly, I noticed that someone mentioned VLAN, but if I remember correctly, within the networking interface, this all takes place at level 3.
Oh, it can take place at any level. So at this particular level, we're matching on DHCP. So this is probably a layer 3 interface. It could take place at a layer 3.5 interface for MPLS. It could also go down to layer 2. So whether it exists at the VLAN layer or at a aggregation point where you're trunking multiple VLANs, including voice and data VLANs, up to a distribution switch, it could take place there. You could run into the same issues if you have it on the physical rather than the VLAN interface, which is where you're going to have your QoS take place. Yes, lots of questions.
How would we differentiate between the IP communicated traffic, since it's coming from PC, and the switch might untrust and mark it as default, right?
How do we differentiate IP communicated?
IP communicated voice traffic
Soft
and data
phone.
traffic.
Oh, soft, okay. There's multiple ways you can do that. Untrusting the interface usually will mean that you have to remark, which is what most folks are going to do. You're going to match. Typically, you'll match on, like you mentioned, you'll either match on the IP address that it's coming from, or if it's on the same IP address, it'll match on the protocol that it's running.
We do a port range for our soft phones. We have a same configuration over and over again for the soft phone, and it has a range of UDP ports.
You'll
and we have an ACL that
You
has
have an
a range.
access group. Yep.
But the caveat is that does consume TCAM. When you have the range, you're going to suck more TCAM up. So that's why you have to push the QoS all the way down to the access layer.
I apologize.
Imagine your destination or your call servers.
Yep. There's quite a few different ways to skin the problem of I have multiple types of traffic coming from a single host. I need to differentiate between those types of traffic. Okay, I'm gonna keep going. I'm running a little low on time here. All right, so we figured out that our engineer is probably have a resume generating event. So let's let's help him out before he gets caught, right? So as a challenge, let's not change our class match, right? We're matching video on SIP. That's dumb, but you know what? Our goal is to fix what he's doing while making the least amount of changes as possible, because maybe this network runs video traffic across SIP. Or maybe their video traffic runs across the SIP port range. And that's what they're using in order. There's many reasons. So we want to make as little changes as possible in order to fix this problem. So here we go. What are we going to do? Boom. The first thing we want to do, move our voice to the top. Why? 1, it's priority. It is priority. 2, it is the most specifically defined. There is only one thing that will match for voice. EF. That's it. My video, if I had to choose between my voice and my video, I'm going to choose my voice because it only has one match statement on a match any. If this was a match all, I might put video first because it's very specific about what it's looking for. Okay?
Match all is non-specific.
I'm sorry, match.
Did you say match all?
But yeah, you can use match all.
That's totally non-specific.
Match all is very specific because it must match every single line underneath the match all statement in order to continue. Yes?
Is there an easy way to reorder the rules in there so you don't have to be like no class voice and erase everything?
I don't think so.
Oh,
The easiest one would be to delete the class map and do it
Yeah.
again. Or delete the policy map and build it the correct way. So that's what we've done here. All right, so now I have my video class. Okay, it is a priority. It is less specifically defined than my voice, but it is still priority, so I put it second. Finally, I have my web traffic. Excellent. But Chris, where's my email go?
What?
Well, maybe. If it's from the TINNet, it's going to go into web.
Class default.
Class default. Don't forget about my class default. It exists down here. We can't see it, but it will exist up here once we start shaping the traffic. It will go into that class default. All right? So what happens to our unused bandwidth? Right? The bandwidth that we're not using. Remember, our policies don't have to assign all the bandwidth. We didn't assign 100% of the bandwidth in that policy. We assigned 40% plus 40%. That's 80%. And then we said 40% of what's left goes to web. That's another 4%. 5%? Yeah. I can't do math right now. Somebody will correct me. That's not 100%. The bandwidth there's still bandwidth there. All my unassigned traffic will go to class default. Anything that's not automatically assigned will go to class default. Any bandwidth not in use can be shared by all queues with the caveats of, hence they're on the screen. My priority classes will get policed. I can share right up until the amount that I'm going to get policed at, and then I can't share anymore. My non-priority classes will share until they run out of bandwidth. Myth number 1. My network is dropping packets, therefore QoS must be broken. My QoS is doing what it's supposed to do. Right? If it's priority, it's policing. That's what the priority. If it's priority and it's hitting that rate that I told it, this is your maximum rate, it's doing what it's supposed to. It's preventing queue starvation. If it's in another class, it's preventing. It is allowing it to use the maximum bandwidth that we've assigned it, and no more. Yes.
One probably saw that led to that myth, or that what makes that propagate is that if you do have misconfiguration, you missed a trust statement, and you have somewhere in the path, one path, marking it to 0, then all of a sudden you're seeing more in your default queue, because when it gets marked to 0, the default queue, instead of the proper queue it's supposed to hit.
You gotta put the new router in.
Absolutely. Oh, please, no. No, this is like my nightmare. I got to drop in the QoS. I got to replace the router. Hooray, we busted it, right? We know, we have an idea about when we get confronted with this myth, we have an idea about how to dispel it now, right?
Except for one case. You have unlimited data plan, and they set the priority for voice and video, but then your data drops, your email and text are slowed down because they don't want to give you the LTE
That's
4G.
that is an entirely different, that is policy-based. That is nothing to do with QoS. We're talking about router QoS here. That is a quality of service policy that is not set by a router. That is an entirely different case. All right, a little bit deeper dive. All right, so hold on to your heads a little bit here. We're going to go a little bit deep into shaping. Interfaces are only capable of sending packets at their line rate. That means if you have a 100 meg interface, you're sending it 100 meg. If you have a 1 gig, you're sending it 1 gig, 10 gig, you're sending it 10 gig, 100 gig, you're sending it 100 gig. I don't care how many packets you send out. They're going out at that rate. You cannot slow them down. With no shapers, it will send the packet immediately. As soon as it gets the packet, process the packet and send it. Full line rate. If the other side is not able to sustain it, for example, the other side is a different media type, it may start dropping. So we instead start pulsing. I'm going to use the word pulse because if I use the word burst, it overlaps with a different concept. So I'm going to say it pulses at a rate that is slower than what the actual line rate is. Now, each pulse is line rate. But I am not streaming data consistently. I'm only going to send line rate every pulse. The time between these pulses is our interval. Remember, that's one of our parts. How long do we wait and how much do we send? Our interval is how long do we wait. Okay? So what happens when we have no shaper? Line rate is all the way across. Whenever I have packets, I hit line rate. What happens when I put a shaper on there? Now, effectively, I get a full line rate burst of traffic. I hold it, and I pulse, and I only send a portion of it. I send that portion at line rate, but then I hold the rest of it and say, I can't send this. I have a shaper. Sit on this. I go for a certain amount of time. I pulse again. I send the rest of it. So I let that sit in the queue. Okay, here's our formula, right? Our interval is equal to our committed burst divided by our committed information rate. I think that's supposed to say ASR. The interval between the pulses can't be directly configured on some routers. You have to configure your committed burst size. So sometimes you're going to want to configure, I want to configure my interval. Sometimes you're going to look at it and say, I want to configure my committed burst size. What we want, ideally, what we want is to see the smallest possible time interval between pulses. Why? You remember that shaper line, that asymptotic line that we approach the CIR slowly? How do we get as close to that line as possible without touching it or going over? We average, but we average across as small of a period as we can. And again, this is hardware matters. Your hardware will determine what that period is. But if I wait 20 milliseconds and send you a burst, it's going to be big. If I wait 1 millisecond and send you a burst, it's going to be much smaller. The more control I have over the size of that burst, the better I'm going to do at approaching what the provider is going to offer me. So note, I have two policies here. First one says policer, should say shaper. All right, it says shaper. I have one at 100 meg, but I've set my interval or my committed burst size such that it waits longer. I'm sorry, the policer is on the provider side. I'm shaping, and I'm shaping to 100 meg. But I'm shaping in such a way that I send him a large burst of traffic. Well, he's still policing me. Remember, I can't just wait a year and build up all that burst and send it to him. So he's going to say, okay, well, I'll take this much and I'm going to drop the rest. But I can change that, use the same provider. I can shrink my interval to half of what it is, and now watch. Every time I pulse at it, I'm still sending the same amount of packets, right? If I take this and I stack it up here, it's the same as this guy. Pretend it is. I'm still getting the same throughput. The difference is my provider is not choosing which packets to drop, I'm choosing which packets to queue, and none of my packets are getting dropped. This is a huge thing, I think, for folks to understand when you're trying to interact with your telco. You want to be below whatever they're doing, and whatever they are doing, if you can't get below it, you want to go as small as you can to try to match what they're giving you exactly. Remember this myth? A couple folks who went, huh? Do we understand this myth now? I'm setting the shaper on the interface. I'm setting the bandwidth statement on the interface. It does not control the speed at which packets leave my interface. The shaper controls how fast, how frequently that burst leaves my interface and how big that burst is. The bandwidth statement doesn't do all that much. When I had folks who told me, oh yeah, I put bandwidth 100 on there, it should know it's a 10 gig circuit, but I put bandwidth 100, it should know that it's 100 meg. All right, some special considerations. Link fragmentation, interleaving. This is less of a problem today than it used to be. This used to be a huge deal. But audio packets, remember, audio packets are tiny. We send a lot of really tiny packets. What happens if I have a big 1,500 megabyte packet from web data, or if I have jumbo frames enabled? I've got a 9,200 megabyte packet of web data that I'm going to send. What do I do with that little audio packet? Well, it sits there while I put all of those bits on the wire. And depending on the speed of the interface, that can cause some serious delay. Even though its priority, it came after I started to send that huge packet. So it's going next, but it's still going to sit there. Now, in the world we live in today of gig, 10 gig, 100 gig, 100 meg, this is less of a problem. This is a huge deal for folks sitting on T1s, MLPP, frame relay, ATM circuits, those small circuits that you may have out to that remote office in the middle of nowhere. Huge deal. This can really help improve the quality of the audio by interleaving, by saying we're going to take that big packet, we're going to split it into two, and then we're going to send the audio packet in between them. Why? Because we can deal with the web traffic fragments. I can't deal with my audio delay. My ear doesn't like that. Speed mismatches. We kind of just talked about this. If I have a link where I'm using 10 gig on one side of the router, comes in, right? I'm in the data center. What is my, somebody's got a data center. Good. Well, what size pipe are you using to come into your data center, transit in and out?
Oh, from outside?
From in and out, yep.
100 meg.
100 meg. Do you have interfaces inside that data center that are gig or 10 gig interfaces?
No, we use 40 gig links.
40 gig links. So you have 40 gig links in the data center, and that's all going to that 100 meg pipe.
No, not all of it.
Well, not all of it.
Nowhere's near all of it.
But what happens if a host on the other side of that 40 gig link decides he's going to take that opportunity to send all of his traffic? He just happens to pick all the traffic needs to go out. This burst right here, all of it's going out that 100 meg link. He goes, yee-haw! Yep. And then he gets dropped. Because as that 40 gig comes in, unless we have enabled QoS on those interfaces to queue those packets and to make sure that we have the correct buffer size for those packets, we can run into a situation where all of a sudden I just got 40 gigs worth of traffic and I need to shove it out 100 meg interface. This is what we call the 2-ton sack of stuff in a 1-ton bag.
Of stuff.
Yes, of stuff. Yes.
Isn't a TCP window supposed to fix that problem?
Isn't TCP windowing supposed to fix that problem?
Yeah, so many using TCP.
It could actually exacerbate it.
Yes,
Retransmit.
in theory,
Yeah.
it might help, but it actually, over a long period of time, will actually, those retransmits start to pile up. And because you're still sending it, 40 gigs. Every time he says, I want to retransmit 40 gigs, there it went. I got 100, right? I got 100 meg, and he's throwing stuff to me, and I've got a little shovel, and I'm kind of, and he drops another 2-ton bag, and I'm sitting there going, come on, man, I haven't gotten the first ton out.
Usually, there's preemptive dropping, so that
Yes,
even when you get up to like 50% or higher, and start dropping.
There are mechanisms like weighted red and different things like that that will help to alleviate the problem. However, this is one of the functions that you're wanting QoS and your buffer sizes to kind of help you take care of. You need to have those buffers sitting in place. This is one of the ones where I've had somebody say, we don't need QoS, right? We already talked to, I don't need QoS. Well, do you ever have a link that goes from 10 gig to 1 gig? Or 1 gig to 100 gig? Or 10 meg to anything larger than 10 meg?
Yeah, we had somebody.
Me to shove this watermelon into the straw.
Yes, you need, at that point, you realize you need QoS. And it's, to some extent, you may be able to get away if it's just 10 meg to 100 meg, you may be able to get away with it. But once you start getting those really extreme differences in speed, 40 gig to, that was perfect, thank you. I'll slip you the 20 afterwards.
We implemented something called Hold Queue in the old days before we did QoS. That kind of tied us over a little bit. Hold Queue would kind of help in that situation, but it wasn't really.
And the function here that we're using, there's 2 methods to deal with this. We have the same link everywhere, or QoS, and I didn't really dive into what all QoS methodologies are here, but setting your Q depth, setting your Q size, appropriately sizing those, setting weighted red, setting early drop detection, those are keys here for dealing with those speed mismatches. Myth number 2, busted. All right. Configuration, I included this here. I think we've gone through this, so I am going to skip ahead because I'm running out of time. We've talked through most of these examples. In the first example, obviously to enable it, we apply the service policy to the interface. Last 3 slides. Troubleshooting. Troubleshooting QoS is fun. It is the bane of everybody's existence, right? Why is my network dropping packets? I don't want to tell you here are the commands to solve your QoS problem, right? Because the answer of hardware matters and it depends really get in here. However, I want you to stop when you have somebody who's calling you, telling you your network QoS is causing my application to slow down and have problems, because that never happens. These are the questions that we want to train them to have when they call us and say, I see drops on your network, you're causing my application problems. These are the questions that we want them to have ready for us when they call. Are there drops? Probably, that's probably why they're calling. But if they just see QoS, if they just say, hey, the quality of my application really went downhill, are there drops? I'm not dropping it. It's getting to where it needs to go. Where are the drops? Huge. Are they where I am taking it? Are they at my policer, where I'm policing their application at that directly connected interface? Are they in the core? Those are hugely different problems to troubleshoot. Are they incrementing? I can't tell you how many times I get the call of, oh my God, there's drops, help. When were the drops? 2 weeks ago. I can't do anything for you. You're done. The conversation's over. What class are they in? This is the big one, right? Am I dropping my voice? Am I dropping my web traffic? Am I dropping traffic that is critical to me? Or am I dropping class default? I'm dropping class default. You know what I'm doing? I'm hanging up the phone and going back to sleep. I don't care. That's what the class default is there for. The class default is there to get dropped. Okay? Is there service impact? Again, this is probably why they're calling you. But if they just saw drops and they're calling you to find out why you're dropping, the question is there service impact? If the answer is no, I'm done. If yes, then what is the service impact? Define it specifically. I have problems is not specific. I have a problem with this application having too much latency from this location to this location. You give me that, I will troubleshoot that in 5 minutes. I can't troubleshoot my application isn't working well.
My favorite is just dropping packets everywhere.
Get a bro. My response to that is it's designed to do that. Next question. Right? Is there voice quality issues? Are there web sessions? Are there application failures? Is it something I expect? Right? So this is where it's key to know your unique snowflake of a network. Where do we see drops and when do we see them? Is it normal to see those drops there? Is it weird to see those drops there? You know, if I see drops in my control plane, I'm concerned. I'm dropping, you know, my BGP or my OSPF packets. That's a problem.
You see things changing with regards to models, like, for example, the data center-centric model that's coming up, where nobody has desktops, laptops anymore, per se. They're all logging into a VDI or some type of a, you know, Citrix client. We're seeing a lot more population of that, and we're being asked by the folks that are in the VDI sessions if we can prioritize the VDI traffic or the ICA traffic. Are you guys seeing that a lot, and maybe inserting that into best practice to market it in higher priority?
I actually can't comment on that because I don't actually deal with that regularly. So I would invite, if there's somebody else who runs into that and would like to answer that question, I invite you to do that afterwards. I'm trying to run through. So the last key one here, can I validate that my packets are marked correctly? This is huge. For most of the networks that I work on, the great news is that, yes, that's not even a question for me. We have people who do that. That is their entire job, and I don't have to worry about the packets being marked correctly. It's not always the case. Even one time I managed to work in a case where the telco was somehow managing to mismark my packets, and so I was experiencing call quality issues in one direction because they decided that they wanted to remark all my packets. I don't know why, I don't know how. We fixed that, but that's the key, right? Is it being marked correctly? Quick reference, a couple commands here. I always think this is useful. Ping to wherever your destination is that's having the application issue, and use the DHCP or IP precedence value that's converted into TOS. You use that value, you ping, so you make sure that you simulate that type of traffic. Maybe it's not going in the right queue. So that can be a useful tool. Finally, how you interact with your telco. So this is probably why everybody's here, right? How do I tell my telco what to do? And specifically, this is a lot of times I'm called in where I'm called in because I act on behalf of my customers as that subject matter expert that can talk to the other experts within the telcos and say, we're doing this, we're doing X, Y, and Z. We expect you to be doing X, Y, and Z. Here's what we're seeing. Tell me what you're saying. This is what I need you to do, or this is what we're going to do. This is where I get called in. So this is what I wanted to pass along to you guys. So my provider told me to blank. Okay? To improve my performance, I need to change my peak information rate. Okay. First question. Are you shaping to your provider? Probably. Are you shaping peak to your provider, or are you doing shape average? If they tell you to change your peak information rate, and you're shaping to your average, you tell them they're an idiot. You tell them that politely. Maybe you don't, depending on your telco. Your shape average will never adjust the peak value volumes. There are some platforms where you can set this number. No, it's like placebo. It doesn't do anything. You say shape average and you set what your peak information rate is, you know what you did? Nothing. You didn't do a thing. Okay? All right, well, okay, now I've convinced them that I'm doing shape average. Are you matching? They want me to change my committed burst value. Okay, well, now we're on the same page. Are you matching the CIR? Is your company's design policy matching the CIR by setting the committed burst value? Or is their design to set the interval, or set the interval by setting the burst value? If you're using TC, you cannot change your committed burst value. Whatever your committed burst value is cannot change because you're setting the interval at which you're sending the packets. Otherwise, you functionally change what your committed information rate is.
Sorry, is that by hardware? Is that second one by hardware?
No.
No, it's by provider?
No. So if your question is, you cannot change your committed burst values without changing your CIR? Is that the question?
No, I mean, how do you know which one you're using?
How do you know which one you're using? Great question.
Especially if you're inheriting somebody else's.
You may not. If you're inheriting somebody else's, you may not know. You can look at the policy. The policy may have it set. Here's my committed burst value, or here's my interval. That would be the best guideline that you could use. If you don't know, if you're the bottom guy on the totem pole and you don't have access to the architect, or you're the architect and you just picked up the other architect's design and you're like, what was this guy thinking? There's not always a great way to go about determining what you are supposed to use.
So if you are the architect, make sure you document that, right?
Yes. Also, we'll get to the second one, and then I think the third one will help clarify that. Remember, finally, I'm using my, they want me to change my interval. Are you following the best practice of setting your interval to the minimum value available on that piece of hardware? Right? Remember, we looked at that. We're looking to set how frequently we're sending packets to the smallest possible value because it hits that asymptote as close to possible of what we want to send, right? So if you're doing this, you're already in good shape. You're doing the right thing. Tell your provider, I'm pretty sure this is in your network. We need you to start looking at your network. If you're not, or if you're not sure about what you're doing, look at matching the provider's interval either exactly or at a lower multiple value. So if their interval is 8, you can set your interval to 8 or 4. You do not want to set it to 7. If you don't have the option of setting it to 8, you may need to work with them to figure out what you need to set it to.
Plausible still.
So, hopefully, we got you on the right path. I know that there's still a lot of topics here to cover. I know we covered a lot, and we covered some of it very quickly. So I'll be up here to answer any questions or one-offs that you guys want to ask of me. Yes?
Just a question for the room. Is anybody using NBAR classification?
I think that's your answer.
Wow. I would expect at least some hands.
What was your question?
Is anybody using NBAR?
One of our customer does.
Okay. There are few, but there are folks out there who use NBAR. It's more common than people want to admit. That's it, folks. Thank you. I hope you enjoyed it.
Thanks, Chris. I think you can see this as a topic, we could actually have QoS Part 1 and Part 2.
Yeah.
And on, because it is that complex topic. All right, so what we're gonna do here